Assalamualaikum and hi, I'm MIRNA AYRA, and today I will be sharing with you about sets, subsets, and set operations. So let's start with the set theory. So what is a set? A set is a collection of objects called elements. So usually sets are shown in these circles called Venn diagrams, and the elements in them are the elements of the set. Okay, so this can be written formally in curly brackets. So we write a curly bracket here, 1, 2, and 7, and we can also give this set a label, which is something like A. So some notes to remember about sets is that repeated elements are only listed once. So let's say we have set A, B, B, C, A. We can also write that as set A, B, C. So you can see that the repeated elements are not written multiple times, and it's okay to write them multiple times, but of course it's neater to write it only once. And next, there is no order of elements in a set. So let's say we are given a set of 4, 2, 3, 1. This also can be written as 1, 2, 3, 4. And it's easier to understand this through the Venn diagram itself, which is in a circle, and that shows that it doesn't have a specific order in where you write the elements. So it shows that there is no order of elements in a set. Next is the elements and their cardinality. So let's say we have set A with elements x, y, z. So let's say the statement x is an element of A. So we can write that as this. X is an element of A. This symbol denotes that x is an element of A. And next, the statement W is not an element of A. We can just write the same symbol, except this time we add a slash. So W is not an element of A. And the next statement is the cardinality of A is 3. So cardinality means the size, which is the number of elements in the set. So how do we write this? We just use the bars of an absolute value. So we just use the bars on A. So absolute value A equals to 3. So this shows that set A has 3 elements. And next, we also have the empty set, which is denoted by this symbol. And just like its name, it's an empty set. So when we write it in curly brackets, we just write the curly bracket with nothing on the inside because it's empty. So the cardinality of an empty set is 0 because it has 0 elements. Next is subset. So what is a subset? Subset is a set which has elements that are all contained in another specific set. So some symbols to denote a subset are these symbols. So let's say we have subset A. So let's say we have set A with the values 5, 4, 3, 2, 1. And then we're also given subset B, which is 2, 3, 5. And then we have set C, which is 5, 6, 7. And then we also have set D, which is 3, 2, 1, 4, 5. So how do we use these notes? How do we use these symbols? Alright, so let's compare these three sets to A. So you see that B has 2, A has 2, B has 3, A has 3, B has 5, and A also has 5. So we can say that B is a subset of A. Why is it a subset? Because it only has 3 elements from set A. It does not have 4 and 1. So it is not equivalent to A. Therefore, it is a subset of A. However, we can't write that A is a subset of B because B does not have 4 and 1. Therefore, A is not a derived set from B. Alright, so we use this symbol. A is not a subset of B. Next, let's compare C and A, where we have 5, 6, 7. We can see that A does not have 6 or 7. So we can say that C is not a subset of A. And then let's compare D to A. We can see that all the elements in D is also in subset A, is also in A. So we can write D is a set that is equivalent to A, or A is a set that is equivalent to D. Alright, so next is the operations on sets. So we have 4 total operations, which are the union, the intersection, the symmetric difference, and also the complement. So the union of set A and B is essentially just taking the elements of A and the elements of B and combining them all together. So in the end, we'll have all the elements of A and B. And then next, the intersection of A and B is essentially just what elements from A overlaps with elements in B. So we'll only be having the elements that overlap or that are the same in A and B. And then next is the symmetric difference of A and B. So this is where you take all elements of A and B, A union B, but those elements are also not part of A intersect with B. I'll show you later. And next, the complement of A, which is essentially just elements that are outside of set A. Next, we have an example where given the universal set U equals to X, where X is an element of Z, which are integers, and 1 is less than or equal to X and less than or equal to 10, where subset A equals to X is a prime number, B, X is an odd number, and C, X is more than or equal to 7. We also have these questions, sub-questions, which we'll be solving right now. So let's start with identifying what are the elements of set A, B, and C. So, of subsets A, B, and C. So, first, we'll be writing those down. A is a prime number. So, what are the prime numbers between 1 to 10, including 1 and 10? So, those are 1, 2, 3, 5, 7, and that's all. So, that is subset A. So, for subset B is X is an odd number. So, odd numbers are all numbers that are not divisible by 2. So, we have 1, 3, 5, 7, and 9. And next, we have C, where X is more than or equal to 7. So that's just 7, 8, 9, and 10. Alright, so now we have question 1, which is A intersect with B minus C. this backslash also symbolizes minus, okay? So we have, let's start by writing down set A, which is 1, 2, 3, 5, and 7, intercepting with B, which is 1, 3, 5, 7, and 9. Then we'll backslash C, which is 7, 8, 9, 10. Also, don't forget the brackets. Alright, so now we have A intercepting with B. So remember I said intercept is when the elements of two sets overlap. So we must find the similar elements. So we have 1, 1, 3, 5, and 7. Alright, so those numbers are overlapping. 1, 3, 5, and 7. Okay, so now we minus 7, 8, 9, and 10. So to minus, in the final result, we'll only be considering the elements in the former subset. So what we do is, we see here that 7 exists in both subsets. So we'll be eliminating that. But in the first subset, the first part of the subset, there's no 8, 9, 10. So we'll completely be ignoring these 8, 9, 10. And in the final answer will only be 1, 3, and 5. So that will be the final answer for question 1. Alright, so for question 2, we have A union complement of C intercepting with B. So let's start with A, where A is 1, 2, 3, 5, and 7. Union with the complement of C. So these are all elements that are outside of subset C. So that will be 1, 2, 3, 4, 5, and 6. Then we'll close the bracket. And then intercepting with B, which is 1, 3, 5, 7, and 9. So then we start by unionizing subset A with the complement of C, which is combining all the elements together. So we'll get 1, 2, 3, 4, 5, 6, and 7. Intercepting with 1, 3, 5, 7, and 9, which is subset B. 1, 3, 5, 7, and 9. So now, intercepting means overlapping. So we'll only be listing down the overlapping elements, which are 1, 3, 5, and 7. So that will be the final answer for the second question. So that is all. Thank you for watching.